All right, everybody, welcome to Math with Grace. Today we're going to be working on Pre-Calculus, Unit 6, Section 1. Section 1 begins on page 5, and it's titled Trigonometry of Oblique Triangles. Now, if you don't remember what an oblique triangle is, the definition is here. It is a triangle that is not a right triangle. I mean, a right triangle is a very specific thing, but we have to be able to work with non-right triangles as well, and so that's what this lesson is about. We're starting off here with the law of sines. Here is our oblique triangle, and to determine the formulas that we need, they draw an altitude and they do all of the things that they normally do to derive such a formula, which of course is on the next page. And you know how much I love that. But let's read this little bit here. It says, ratios of the sine of an angle to the side opposite that angle are all equal. So the sine of B over B is equal to the sine of C over C. Remember, the capital C is the angle, the little c is the segment, right? Sine A over A. Those ratios are all equal to each other, and this is the trigonometric formula known as the law of sines. Let's turn the page. So at the top of page 6, we actually have the formula for the law of sines. As you can see, it's 3 ratios, and so to use this formula and solve with it, we need to choose which two pieces, which proportion we're going to set up and solve, okay? It says to use the law of sines, you only need to know 2 sides and 1 angle, or 1 side and 2 angles. And it doesn't matter which 2 sides, but obviously the 1 angle kind of needs to go with one of those sides. And when it has 1 side and 2 angles, the 1 side and one of the angles need to correspond, okay? We have to have one whole ratio to be able to solve. We have to have 3 parts of our proportion. If we're using these 2, we have to have 3 parts. If we're using these 2, we have to have 3 parts. If we're using the A and the C's, we have to have 3 pieces of that, okay? So let's take a look at this example. Find the length of A in the given triangle. Okay, so they've given us this triangle. We know the measurement of angle A. We know the measurement of angle B. We could figure out quite easily the measurement of angle C. All right. They've given us side B, because we know it's B because it's opposite angle B. Opposite angle A is side A. Opposite angle C is side C. Okay. They want us to solve for side A. That means we're going to use angle A, sine of angle A, over side A, and then we're going to use B because we have both parts of B. All right? So with both parts of B, those are the 2 we're going to put together into our proportion. We substitute the information that we know. Definitely going to be calculator work. Make sure your calculator is set on degree mode and not radian mode. We've used radian mode in the past. Make sure you're set back to degree mode, and then solve. Now, they didn't really use a calculator. They substituted the values from the charts and things that we've been using because we know that these are exact values. I think if the instructions say find the exact value, then this is kind of what they're looking for. If the instructions do not say that, honestly, I would have just used my calculator and multiplied it out, okay? But the answer is 5 times the square root of 2, which is A. Now, we could also solve for C. You could solve the whole entire triangle, all the parts you could find with this formula, but they only asked for 1 piece, so that's what we did. Taking a look at this next example here, we have in triangle ABC, and they didn't draw it, and that's fine because we don't need to see it drawn. A is 18, angle A is 45 degrees, and angle B is 105 degrees. This time they want us to find side C. We know angle A and angle B, therefore we could figure out angle C, because even in even in an oblique triangle, there's only 180 degrees to go around. So to find angle C, you take 180 and subtract the two angles that we have. So angle C is 30 degrees. And then we use angle A and side A as our proportion. So we have angle A, the sine of 45 over 18, equals the sine of 30 degrees over C, which is the piece that we're missing. And then they solved. Again, they used exact measurements. In the homework, you'll have to wait and see what we have, whether we have exact measurements or not. It says here, since polygons with more than 3 sides can be broken down into triangles, the law of sines can be used to solve problems, including other polygons. It says in this parallelogram, BC is 8 inches, angle B is 110 inches, and diagonal AC is 12 inches. Find the measure of CAB. Okay? We're trying to find the measure of this angle right here. So the sine of this angle is to its side, as the sine of this angle is to its side, right? That's what this is set up. That's the proportion, the ratios that we've made. Sine of A, well, it's not angle A, it's this angle, right? Opposite it is the 8. So they're saying the sine of x equals 8 over 8 is equal to the sine of 110 over 12. Now, obviously, calculator work done here, right? We have to use the inverse sign. It's not really the inverse sign, but on your calculator, you'd have to use that little -1 to go from a decimal value to a degree value. Or you could use the trigonometric chart that we've had in the past, okay, to switch from one to the other. Now, on to this next example on page 7. It says here, it says here that it's not always practical for surveyors to use a right angle, and so we are using oblique information, right? We have an oblique triangle here. To find the distance from an observer's point, which is point A, so someone's standing here looking out on one side of the river to this point on the other side of the river, a line AB is measured, so we know that this part from this point to this point is 2,540 feet. Okay, BAP and ABP were both measured, so they got both of these degree measurements from this, based on this point, right, and their straight line, and found that it was 47 degrees 20 minutes and 78 degrees 10 minutes respectively. Find the distance from A to P. So we have that distance is technically side B, right? We have side B available, but we don't have is 2 parts to side A, right? We have the angle measurement for angle A, but we don't have information about side A. But we do have information about side C from angle P, or you can call it side P, I guess. What we need to do first, just like we did in this example here, is we need to solve for the angle measurement of this angle P. And there's a little reminder up here if you do not remember how to work with degrees and minutes and seconds. Here is your little reminder. But again, it's 180 minus those 2 measurements, and it ends up being 54 degrees 30 minutes, or 54.5 degrees. Okay, 30 minutes is half of a degree. And now we can set up our proportion, right? Because 54.5 degrees is to 2,540, as 78 degrees 10 minutes, although they wrote 7, they changed it 2 degrees here, is to side D, or the distance that we're actually solving for, okay? They changed it over from 78 degrees 10 minutes to full degrees. Let's grab our calculator and remember how to do that. Okay, so if I have 78, and remember this little degree, comma button, so 78 degrees, I want to make sure it's seeable here, 10 minutes, oh, and that's okay that it says degrees again. If I hit equals, it's going to say 78 degrees, 10 minutes, right? And then if I hit that same button again, the little degree, minute, second button, it changes it over to just degrees. So 78.16 repeating degrees, so that's why they have 78.17 degrees here, okay? So that's a quick review of how to switch that back over. And then they solve, and they find out that that distance is 3,053 feet. That is a very, very wide river, right? Over a mile wide river. So that would be impractical to put together a right triangle for that. Although I suppose you could have just, anyway, that's besides the point. All right, so the formulas are here, right? These are the law of sines. You need 3 parts of any 2 ratios to solve, right? Let's turn the page and do some of these problems together. On page 8, looking at problem 2, it says in triangle ABC, if angle A equals 120 degrees, side A equals 8, and side B equals 3, then angle B is equal to what? Round your answer to the nearest degree. So we have the sine of 120 degrees is to 8, as the sine of angle B is to 3. Okay, now in a proportion, remember, to solve we cross multiply. So we're going to have 3 times the sine of 120 degrees is equal to 8 times the sine of angle B. To get angle B by itself, we're going to divide both sides by 8. Okay? This is what's going into my calculator, which will give me the sine of angle B. Remember, not the measurement of angle B, but the sine of angle B. Hopefully this is seeable. Let's see here. No, of course not. Oh, calculator works the trickiest. Okay. So we have 3 times the sine of 120 degrees, closing my parentheses, okay, divided by 8 equals, it's a decimal value, right? This is our sine of angle B. So it's 0.3248, basically rounding, but I'm not going to round. I'm just going to leave my answer as it is on the calculator, and then I'm going to hit shift sine -1, and then I'm going to put the answer in there. I'm putting this answer in, right? Closing my parentheses, equals 18.95 degrees. It says round to the nearest degree, so it is 19 degrees. All right. It says for number 3, in triangle ABC, A equals 18.2, angle B equals 62, and angle C equals 48. Find B. Now, this information is too spread out because remember, we need a matching side and angle, and then either another side or another angle. Here we have one piece of each, and that's too many different things. But we can find the measurement of angle A because we know that B is 62 and C is 48. So 180 minus 62 minus 48 tells me that angle A, and I'm not going to bother making sure you can see this, that's pretty simple math, but it's 70 degrees. Okay, so angle A is 70 degrees. Now we can set up our proportions, right? So we know that the sine of 70 degrees is to 18.2, as we're looking for side B, so we're needing angle B now, sine of 62 degrees is to side B that we don't know, okay? So cross multiplying, I'm going to have B times the sine of 70 degrees equal to 18.2 times the sine of 62 degrees. I want B by itself, so I'm going to divide by the sine of 70. No, you cannot cancel out the sine part, right? That's not how this works. But now we can solve for B. So into our calculator. In a way we can see it. We have 18.2 times, oh, this stinking ring light always messes it up, times the sine of 62, close my parentheses twice, and then I'm going to divide by the sine of 70, closing that parenthesis, equals, okay, 17.100. It doesn't say anything about rounding, but this is our side B. B is equal to 17.1. Now the answer tells us that we need to round because the answer is letter B. B is equal to B. Interesting. Okay. Let's take a look over here at number 8. A 10-foot ladder must make an angle of 30 degrees with the ground if it is to reach a certain window. Okay. What angle must a 20-foot ladder make with the ground to reach the same window? Oh my gosh. Okay, that's interesting. Okay, so we are looking for this degree measure, right? We know this degree measure, and we know that this is how big? This is a 30-degree angle, so to reach a certain window. 20-foot ladder with the, oh, we know that this is 10 and this is 20. That's what we know. We don't know how high the window is off the ground. So we're dealing with this oblique triangle right here, right? We know that outside of the triangle, this is 30 degrees. So we can figure out what this is because opposite rays form a straight line, right? These are supplementary angles, which tells me that this is a 150-degree angle. So now I have an angle and its side, and I'm looking for an angle, but I have its side. So let's set up our proportion, right? The sine of 150 degrees is to 20, as the sine of x is to 10, right? Cross multiplying. 10 times the sine of 150 is equal to 20 times the sine of x. Divide both sides by 20. And now I have the sine of x by itself. But remember, we want an angle measurement. So we're going to need to make sure we do that correctly. See if I can find a spot here. All right, so we have 10 times the sine of 150 degrees, close our parentheses, divided by 20 equals 0.25. Now remember, that's the sine of our angle. Now we need to find the angle, so we hit shift inverse sine, or it's not quite the inverse. We learned that last time, right? Or not 25. What am I doing here? Remember, we just put the answer in, and that answer will go in there. Close our parentheses. So 14.47. So x is equal to 14.47 degrees, or here where it says 14.5. Okay, so filling in the information we know was necessary here to be able to solve this particular problem. Okay, I'm going to leave the rest for you because I feel like these proportions are pretty straightforward. But if you have any questions, of course, let me know. So finish off the rest of these problems. I think there might be, one on the next page. Finish these off and then meet me back here for the next part of section 1. The next part of section 1 begins on page 11. And here is where our law of sines is no longer super straightforward, or that straightforward, right? It says ambiguity and area of a triangle. Ambiguity means that we're missing something, right? So it says here, you may recall from geometry that a triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the third side. Therefore, you know that it is impossible to construct a triangle with sides of a 2, and a 5, because 2 plus 2 is not greater than 5. The law of sines can also help you determine if it's impossible to construct a triangle given certain conditions. Now, they're just restating the law of sines and the information that you need. So let's take a look at example 11. Is it possible to construct a triangle ABC with angle A equals 30 degrees, side A equals 2, and side B equals 6? Use the law of sines to solve for angle B. Now, they set it up like normal, cross multiplied, and it tells us that the sine of B is equal to 1.5. Well, we know that the sine cannot be greater than 1, therefore, this is not a possible triangle with these measurements. It does not work, okay? So that's just one way to use the law of sines to determine if the triangle is even possible to be made, right? Let's turn the page. At the top of page 12, we have another example. In triangle ABC, angle A is 30 degrees, side A is 8, and side B is 12. Find the measure of angle B to the nearest tenth of a degree, right? Again, setting up our proportion, solving. We find that this solution tells us that B is 48.6 degrees. Now, but here's where we need to be cautious that it says. Now recall, there is an obtuse angle that also has a value of 0.75, right? The sine is 0.75. Remember from our unit circle, right? Some angle measurements have the same sine and cosine values, even though they're different measurements, right? So if B is 48.6 degrees, then C would be 101.4. But if B were 31.4 degrees, which is the same sine measurement, right? You took 180 and subtracted the original one to get the one with the exact same sine value, then C obviously would have to be 18.6 degrees. We can only have one obtuse angle in our triangle at once, right? So it could make this triangle or it could make this triangle. Technically, there are two possible triangles from the information that we were given, okay? Either one is a proper solution, and sometimes we need to list both of those measurements, okay? Here is a way to figure out how many possible triangles we're going to have. Side A, now, of course, these can be switched to C or whatever you have, whatever is available, you know. But side A has to be, if side A is less than B times the sine of A, then no triangle is possible. If side A is equal to B times the sine of A, then one triangle is possible. And I'm not sure why they switched it around this time, but if side A is greater than B times the sine of A, and at the same time, I guess, less than B, then two triangles are possible. So this is a little chart. It's very important. We need to make sure we are referencing so that we know when we're doing our work how many possible triangles are available, and we list all of the information. All right. Next little topic here is the area of a triangle. Now, the regular formula for an area of a triangle is 1/2 base times height, right? Base times the height. But we don't always have that information. And so they've derived another formula up here. And they are calling it K because they don't want to get confused with angle A or side A, so now they're calling the area K, and K is equal to 1/2 side A times side B times the sine of C. So now we have 1, 2, 3 pieces, all different, right? We have different parts of all of the triangle. Taking a look at an example, it says, find the area of the given triangle to the nearest 10th. They've given us side C, side A, and angle B. So the area is going to equal, K is going to equal 1/2 side times side included angle, okay? We have to have an included angle to be able to use this formula, right? 2 sides times the sine of the included angle, okay? This B is the included angle, so that's our sine. They put in the information, they multiply, right? I mean, it's just a formula. And they get 24.4 square units. Since a unit wasn't listed, they just call it square units, okay? Because area is squared, we have to reference that somewhere. So if they don't give you a unit, the way to reference that it's a square unit, you just write square units, okay? Next example here on the last one on page 13. The area of an equilateral triangle is 8 times the square root of 3 square inches. Find the length of a side of the triangle. Remember, equilateral triangle, all the sides are the same. This time they've actually given us the area. So 8 times the square root of 3 is equal to 1/2 of side times side, or side squared, times the sine of 60 degrees. I guess since their answer had a square root of 3, they just went with the answer, the exact answer. Let me see if I can find my paper quickly here. Probably not, because it's been a break. Well, I don't have it right here, but you know the chart that we've been using this whole time. It's in my other folder, but that's where they got this square root of 3 over 2, right? And then they just solve. They get to here, to unsquare, you have to take the square root, and then they simplified their square root to 4 times the square root of 2 inches, okay? All things we've been doing for a while now. This area formula is something a bit new, but not undoable, right? These are formulas. We substitute in the information that we know and we solve. All right, let's turn the page and do a couple of these problems together. Okay, problem number 13 on page 14. Determine the number of possible triangles, ABC, that can be formed given angle A is 30 degrees, side A is 4, and side B is 10. So we need to determine, is side A greater than, less than, or equal to B times the sine of A, right? That's what that is. That's the formula for determining the number of triangles possible, right? So 4 is less than, equal to, or greater than 10 times the sine of 30 degrees. So grab my calculator. 10 times the sine of 30 degrees equals 5. So 4 is less than 5. Because 4 is less than 5, remember that chart is just right here on the next page. Because 4 is less than 5, there are 0 possible triangles that can be made. Let's do another one of those. Number 14, determine the number of possible triangles that can be formed given that angle B is 45, side B is 4, and side C is 5, okay? This is the information we use, except this time it's going to be B is greater than, less than, or equal to C times the sine of B. So 4 is what to 5 times the sine of 45 degrees. Okay, again on our calculator. 5 times the sine of 45 degrees is 3.5. So 4 is greater than 3.5. Okay, now looking back, 4 is greater than 3.5, but less than 5, right? Sorry, I was looking for, it's over here. But less than 5, so there are 2 answers available. All right? So that's how we do those. Let's take a look at problem number 19. Find the area of the given triangle to the nearest square unit. Again, so they're not giving us units. They are giving us a triangle here. We have angle A, but we don't have side A. We have angle B, but we don't have, or we do have side B. And then we don't have any parts of C. Now remember, for this formula, which is K equals 1/2, what is it? A times B times the sine of C, right? Generally. To use that formula, we need 2 sides and an included angle. And right now, we do not have that information. So we need to use something else so that we can solve for that. We need to solve for C, and then we will have 2 sides and an included angle. To solve for C, first we need to solve for angle C. Well, this one's 45 and this is 30, so 180 minus 30 minus 45 gives us the measure of angle C. What is that, 105 degrees? Right, this is 75, okay. So C is 105 degrees. Now we can solve for side C. This is like a side quest in doing this problem. So the sine of B, which is 45 degrees, is 210, as the sine of 105 is 2C. That's what we're trying to solve for. So C times the sine of 45 is equal to 10 times the sine of 105, dividing both sides by the sine of 45. Okay, and we'll get side C. So in my calculator, goodness gracious. All right, I have 10 times the sine of 105 degrees, closing my parentheses, dividing by the sine of 45 degrees, closing that parenthesis, gives me 13.66. So C is equal to 13.660. I'm not going to round it to 14 just yet because I feel like sometimes in these problems we round a little bit too early. So I'm going to leave this as 13.66. I know it's rounded, but if you round it to 14, you're rounding it even more abruptly. And now I have enough information. I have 2 sides and an included angle, which is enough to solve this area. So 1/2, both of the sides, so excuse me, 10 and 13.66, and the sine of the included side, so the sine of 30 degrees. All right, so I have 10. All right. Here we go. 10 times 13.66 times the sine of 30 degrees. Oops. 30 degrees. Close my parentheses. Divided by 2, right? You could multiply it by 1/2. I'm going to divide by 2. It's the exact same thing. So the area, or K, is equal to 34.15 units squared, or square units. You can write it like this too. It's whatever the unit is squared, or you could write out the word or the words square unit. It's up to you. It doesn't matter. Same thing. Okay. So we had to take a side quest first to get the parts we needed to use this formula, but that was no big deal, and we did it. Okay, let's do one more. Number 20. A triangular lot bounded by 3 streets has a length of 300 feet on one street, 250 on the second, and 420 on the third. The smallest angle formed by the streets is 36 degrees. Okay, we are going to draw this out because it's telling us the smallest angle. So we need to make sure we know what that means. So one is 300, one is 250, and one is 420. Okay. The smallest angle, remember from geometry, is going to be opposite the smallest side. So this angle here is 36 degrees because it's opposite the smallest side that we have. All right. Find the area of the lot. We have all the information that we need because we have two sides and an included angle. So it's going to equal 1/2 300 times 420 times the sine of 36 degrees. Okay? And there we go. Let's do it. So I have, try to position my calculator here, 300 times 420 times the sine of 36 degrees divided by 2. And that is going to be equal to 37030.470, so 0.47 units squared, or feet, I guess, because they told us feet, right? The answer always wants it a certain way. We would be rounding a 0 based on a 4, so our 0 wouldn't change. So 37030 feet squared. 37030 feet squared, letter C. Okay? Right, so this time drawing it out helped us to position all of our parts and figure out what went where. All right, go ahead and finish these problems and meet me back here for the next part of this section. The next part of this section begins on page 16, and it's titled Law of Cosines. Okay, we did law of sines. Now we're looking at the law of cosines. It says the law of cosines can be used to solve problems when two sides and the included angle of an oblique triangle are known. So two sides and the included angle, just like we were doing with those area problems, okay? It's very specific, the information that we need. All of this right here is them deriving the formulas, and they are right here. Okay, these three formulas, they have it set up in all of the ways you would need, are the formulas. What you need to take note, if you have the cosine of angle A, or just the measurement of angle A, then the A squared goes here. If you have angle B, the B squared goes here. Same for angle C, the C squared goes there, and the rest is the same, right? Okay, so pay careful attention to these formulas and notice that the side of the triangle on the left of the equation is opposite the angle used, okay? The angle used is an included side between the other two sides of the triangle. These three formulas all do the same thing. They just set them all up so you don't have to, like some of the other ones we were kind of maneuvering. Here you go. It's all set up for you every which way till Sunday, right? Let's take a look at this example. In triangle ABC, side A is 8, side B is 6, and angle C is 60 degrees. Find side C. Okay, we have up one piece of each, right? Not really possible for us to find the information that we want. I'm not sure why they didn't write it in here. This is 6, this is 8, and this is 60. Right? Now, technically, could we do that? No, we don't have enough information to do the sines either, right? The law of sines, we don't have enough information for that. But we have two sides and an included angle. So we can use the law of cosines. Because we are looking, we have angle C, and they're having us solve for side C, right? We're using this formula here. That C squared is going to equal A squared plus B squared minus 2 times A times B times the cosine of C. Remember, cosine, make sure you're using your cosine button. This part cannot be subtracted here, right? We have to follow our order of operations, right? It can't be subtracted till this point, and then we solve. Okay? Make sure you are simplifying your radicals. The next example, in triangle ABC, side B is 3, side C is 6, and angle A is 120 degrees. Find the measure of A to the nearest whole number. We have two sides and an included angle. We are going to use this one, right? And again, we put in our information and we simplify, okay? Careful here, because the cosine of 120 degrees is a negative 0.5. Negative times negative makes it a positive. So be careful with your signs. And this time, I think it's kind of funny that they took the square root and gave a decimal value, where here they did not. I do not like decimal values unless we were given a decimal value in our provide information. I would prefer this just to say the square root of 63, which is what? Let's see. So we have 63, 3 goes into that 21 times, 3 goes into that 7 times, so 3 times the square root of 7 is the answer, right? Rather than this is better, in my opinion. It's interesting that the book goes back and forth sometimes. All right, let's continue. Turn the page. Looking at this example here at the page 18, it says an engineer is planning to make a tunnel through a mountain. From a point on one side of the mountain, she cites a distance of 0.2 miles. So she's standing right here, 0.2 miles to this bottom part of the mountain. And she's standing this very small mountain, okay? And she's standing here. This is 0.3 miles to this side of the mountain. And the measure of the angle between those two views, those two sightings, is 111.5 degrees. To the nearest tenth of a mile, how long will the tunnel be? What is the length of this side? We have two sides and an included angle, so we will use that formula that tells us that x squared, so this number squared, is going to be this squared plus this squared minus 2 times this times the cosine of this, right? We don't have the a's and b's. Feel free to label it if that helps you. But that is what's going on here. The answer is 0.41 or 0.4 miles long. Now, again, this is a technicality. The answer is approximately 0.41. If you went to 0.4, you might not break through. I technically would have rounded this up because a tunnel has to go all the way through, right? You don't want to get to the last 0.01 and then stop, but you know, that's just silliness, kind of, okay? So the tunnel is 0.41 miles long, all right? Next example, a bomber flies north at a rate of 650 knots and another flies west at 600 knots. If both start from the same place at the same time, how far apart will they be in 3 hours? Okay, this is probably a story problem. People are like, oh my gosh, I didn't understand any words that you just spoke, okay? A bomber is flying north at 650 knots, and another one is flying west, right? Never eat shredded wheat, at 600 knots. I like to draw things. It helps me to see what's happening. If they both started at the same point, which they did, at the same time, how far apart will they be in 3 hours? This is what we're solving for right here. How far apart will they be in 3 hours? Now, in 3 hours, this guy flew 1,950 nautical miles, and this guy flew 1,800 nautical miles, okay? It's 3 times this is this. 3 times 600 is 1,800, okay? Since one plane is flying north and the other is flying west, this is a right angle. Okay, this is a right triangle. We can use the Pythagorean theorem to solve for the hypotenuse, which is what they have done. And at 3 hours, they will be 2,653.8 nautical miles away from each other. All right? So this one had nothing to do with the law of cosines, but that's okay. They do use the law of cosine here to show that it's the same. So let's do some of these problems. In triangle ABC, B is 12, C is 15, A is 60 degrees. To the nearest 10th, what is A? So A squared, they didn't really give us a lot of room here, is going to be equal to 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 60, right? That is the formula. So A squared is equal to 144 plus 225. Oh, I wrote an equal sign again. Minus, no, this, I got to grab my calculator. Minus, turn on, silly thing. 2 times 12 times 15 times the cosine, make sure you're doing cosine, of 60 degrees, closing my parentheses, equals, so minus 180. So A squared is equal to 144 plus 225 minus 180, or 189. I know that that is not a perfect square, so when we take our square root, we need to figure out 189. Now, some of you got some pretty fancy calculators out there. I wonder if this one will do that. Let's see. Well, if my calculator does it, I don't know how. But I know someone has a calculator where they take the square root and it actually tells them the answer and it reduces the square root, which is kind of cheating, I think. So 3 goes into 189, what, 63 times. 3 goes into that 21 times, and 3 goes into that 7 times. So A is equal to 3 times the square root of 21. Okay, is equal to 3 times the square root of 21. I'm a big proponent to putting our answers in the correct place. So 3 times the square root of 21 is A. In triangle ABC, A equals 9, C equals 5, and B equals 120 degrees. Find B. Angle B is 120, so find side B. So this time, B squared is going to equal A squared plus C squared minus 2AC cosine of angle B, right? That's the formula. So B squared is equal to 81 plus 25 minus 2 times 9 times 5 times the cosine of 120, okay? So B squared is equal to 81 plus 25 is 106 minus 2 times 9 times 5 times the cosine of 120 degrees, close my parentheses, which becomes a negative 45. We can't have a minus minus in math, so this becomes a plus. So B squared is equal to, what is this, 151? Yeah, 151. And the square root of both sides. 2 is not going into 151. 3 is not going in. No, definitely not 4. So I'm pretty sure 151 looks like it's going to be 7. No. 13? No. So looks like 151 is a perfect root. So letter D. All right. Did I mark one on the next page? I did. All right, so let's turn the page and do another one together. On page 20, number 29, it says, in the diagram below, points A and B represent 2 airplanes. How far apart are these airplanes? Okay, well, this one has gone 840 miles. This one's gone 800 miles. This big angle is 150 degrees. This small one is 45, which tells us that this one here is 105 degrees. So we have 2 sides and an included angle, and so we can determine what that other side is going to be. So I'm just going to use the labels I use. D squared is going to be equal to 800 squared plus 840 squared minus 2 times 800 times 840 times the cosine of 105 degrees. Okay. 800 squared should be, what, 6,400? Oh, no. 640,000. Oh, right, because it has 4 zeros. Okay. So 84 times 84. Oh. It's not 84. It's 840 times 840 is 705,600 minus, goodness, these are big numbers, 2 times 800 times 840 times the cosine of 105 degrees, close your parentheses, it's going to be a negative number, negative 347852.7966. Yeah. I'm just going to leave the decimals there for now. It doesn't hurt me one way or the other, right? We can't have a minus minus in math, though, so we're going to add. So d squared is equal to this number that is on my calculator, but I have to change it to a positive number, times a, times a negative 1 gave me a positive number, plus 705,600 plus 640,000. 1, 2, 3, 4. My eyes aren't great, so I have to count my zeros. All right. Equals. So d squared is equal to 1,693,452.797. So the calculator already rounded for me. Because these numbers are quite large, we're just going to go ahead and find the square root. And that is going to equal 1,301.327. The answer wants it rounded to the nearest whole mile. We're rounding a 1 based on a 3, so the 1 stays the same. So the letter answer is D. All right? Okay. I'm going to go ahead and let you finish the rest of these. We have one more part of this section to cover. So when you're done, join me back for those. All right, the last part of this section 1 is the law of cosines, finding an angle. It says the law of cosines can be used to solve for missing sides of a triangle, or a side of a triangle, when the other two sides and the angle opposite the known side are known. Solve for a missing angle measure when all three sides are known. You can also solve when all three sides are known. There is no ambiguity when we're talking about the law of cosines. Here's our example. In triangle ABC, A is 12, B is 5, C is 10. Find the measure of angle C. Okay, so because we're looking for angle C, we're going to use the C squared equals A squared plus B squared minus 2AB or cosine of C. Okay, they put in all the information we know. Obviously, we don't know the measure of angle C. That's what we're solving for. You cannot subtract these two numbers from each other. It does not work, right? This 120 is part of this cosine of C. So this actually needs to be subtracted over here instead, which gives us a negative 69. Now you divide by 120, negative 120, and then solve for your cosine with the inverse cosine button. And they find that the measure of angle C is 55 degrees, okay? So make sure you're moving this, not trying to combine these two things, right? Those are not like terms. We can't do that, all right? Let's turn the page. Example on page 22 reads, the sides of a triangle measure 3, 5, and 6. Find the largest angle of the triangle to the nearest degree. Now, if you need to draw it, that's fine. 3, 5, 6. Remember, the side, or the angle opposite the largest side is the largest angle. They're talking about the largest. One of the other examples, right, they gave us the smallest angle, so we would have used the smallest side, but here they want the largest. So here are my sides and my included angle to solve for that one. Okay. The shorter diagonal of a parallelogram is 2 feet. Okay. Remember, for this example, a parallelogram looks like this. It has 2 diagonals. The shorter diagonal, the longer one would be this one. It's more stretched out. The shorter one, it says, is 2 feet. To the nearest degree, what is the largest angle formed by the sides of the parallelogram if they measure 3 feet and 4 feet? So this is 3, let's say, and this is 4. The largest angle formed is actually this angle here. But with the information that we're given, we're going to be solving for this angle. Okay? This is what we're solving for. To find the measure of this angle, we would have to subtract this from 180 because remember, in a parallelogram, adjacent angles are supplementary. Okay? And that's what they've done here. They solved for this angle and then subtracted it from 180 degrees to get the measure of this largest angle. Okay? So by drawing it out, we were able to see what was going on. I strongly suggest drawing out your work. Okay? Let's take a look here at number 33. For number 33, it says in triangle ABC, A equals 3, B equals 5, and C equals 7. Find the measure of angle B. So we're going to have B squared, or 25, is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. Right? That's our formula thus far. So I have 25 is equal to 58, right? 9 plus 49 minus 2 times 3. I don't want to rewrite all of that for no reason. Let's just go ahead and do the math. 2, although I can do that in my head. That's kind of silly. 42, right? 6 times 7 minus 42 cosine of angle B. Okay. I'm going to subtract 58 from both sides. When I do that, I have 25 minus 58 is 33. Negative 33 is equal to negative 42 cosine of angle B. I'm going to divide both sides by a negative 42. So it's going to be a positive. So 33 divided by, let's just keep it negative, 42 is equal to, I don't know if you can see that. I know you cannot see that. 0.78571 is equal to the cosine of angle B. I'm writing it down like that, but I'm not going to round it right now because I can easily just hit the cosine, or not cosine, the negative cosine or the inverse cosine of that answer, that whole big decimal, close my parentheses, equals, and it tells me 38.21. So B is equal to 38.21 degrees. They want it reduced all the way, so 38 degrees. Okay? All right. Let's see, is there a different one I started? No. We're going to go ahead and finish the rest of these on your own. Of course, if you have questions, do not hesitate to contact me. But that is the end of this section. So again, questions, contact me. Otherwise, until next time.